Good morning, sir. Good morning, and welcome for the Alumni webinar series for the mechanical engineering students. The current today's topic will be the current trends in e-vehicle and hybrid vehicle. Now I welcome Kavita Sri to introduce about the CPS.
Good morning, everyone. It gives me great pleasure and honor to welcome you all to this exciting webinar on current trends in electric vehicles and hybrid vehicles. Today, we are privileged to have you with us, sir. Mr. Vairam is a distinguished manufacturing engineering lead specialized in BIW assembly and boasts an impressive 11 years of experience in the automotive industry. His journey has been filled with remarkable achievements, contributions, and a relentless pursuit of excellence in various facets of manufacturing engineering. As an experienced professional, Mr. Murugan has played an important role in automotive BIW new model launch, where his expertise in planning, development, industrialization, quality, and project management has been instrumental in bringing cutting-edge vehicles to life. With a background in BIW assembly design, he is well versed in the intricacies of DFMEA, design failure mode and effects analysis, JIG design, facility planning, simulation, quality, assurance, cost reduction, and standardization. As an alumnus of a college, Mr. Murugan holds a special place in our heart, and we take immense pride in his remarkable achievements in the automotive industry. Today, we are fortunate to have him back on campus, only to share his invaluable knowledge and insights into the current trends in electric vehicles and hybrid vehicles, but also to inspire the next generation of mechanical engineers. I encourage all of you, dear students, to seize this incredible opportunity to learn from Mr. Murugan's vast experience, knowledge, and expertise. The world of electric and hybrid vehicles is rapidly evolving, and with Mr. Murugan's guidance, you will gain valuable insights that will undoubtedly shape your own career paths and aspirants. Let's extend a warm welcome to Mr. Murugan as he imparts with knowledge, experiences, and vision for the future of automotive engineers and the sustainable mobility revolution. Thank you for being here with us, sir, and for generously sharing your time and expertise with our college community. Now, I present to you our esteemed chief guest, Mr. Vairam Murugan. Let's make this webinar an enlightening and enriching experience for all. Thank you.
Thank you very much for your kind introduction, and it was a lot for me. Yeah. Is my audio clear? Can you hear me?
Yeah.
Yes, sir. Okay. Thank you. Thank you. Good morning to everyone and all faculties and students. Thank you very much for this opportunity. It's my pleasure to join with you all during this time. Okay, let me share my screen. Please let me know if you can see. One moment, please. Yes, is my first title screen is visible?
Sir, yes, sir, it's visible.
Yeah, okay. Thank you. Okay, just a moment. Okay, clear. Okay, so let us start the topic. And so today, let me share some informations about latest technologies in electric vehicles. So moving to before we start, I hope you can hear me. Okay. Before we start, why do we need to switch to EV? Can anyone, some of you can say some reasons?
Louder. Speak loudly.
Sorry, I'm not able to hear properly.
To reduce the pollution, that is the first answer the
Yes.
student has given.
Okay, thank you.
And second one, availability of fossil fuels.
Exactly. Okay.
Okay, hike in petrol price, and the next one, global warming.
Okay, great. Okay, yes, almost same, like everyone knows. So it is environment friendly, as you said, less emissions, and we have exponential increase in fuel price, and it is comparatively cheaper for maintenance once you buy it, and operation cost is less, and we are getting some subsidies or tax benefits for switching to electric vehicles, right? So just as a basic points, I want to share some statistics. As we all know, previously, maybe 10 or 15 years back, we never thought EV will have this much market share. So as you can see, in last 10 years, it is an exponential growth. So it was just 0.2% in 2013, and it is now more than 13% as a current situation. And what you can see, green is battery electric vehicles and plug-in hybrid vehicles also. So this growth in electric vehicle share is forecasted to increase further. By 2030, it is expected to grow until 22%, and by 2040, there is possibility for crossing, like outselling the IC engine vehicles. So, like, and moving to top EV makers. So China is already way beyond other countries, as you can see. China is almost 4 times higher than other countries. Even the big giants also, China dominates in this EV industry. There are several reasons for it. I can explain in coming slides. So in regional sales also, you can see there is a drastic growth for China and Europe, North America, and others are very less currently. But still, you can see the development rate, it is more than 90% in 1 year. So it is promisingly increasing market. So if you see each OEM, so you can see BYD and Tesla, which is dominating the electric vehicle industry, is having more than 40% of share, more than 50% share it is having, and all the remaining auto giants are still in line. So what is missing here? Like, what do you feel odd here? Any points from anyone? Like, yes, I request it will be more better if we can have an interactive session. So if it is one way, it will be difficult to hear. So you can see whatever highlighted in red, it is already well-established automotive giants, right? So they are still way beyond the BYD and Tesla. So because they are like, it is not their core area. So once BYD and Tesla, they start from electric vehicle alone. So the only focus for them is electric vehicle. But already established automotive giants like Mercedes-Benz or BMW or Stellantis Group, Ford, Toyota. So they perform very well in IC engines, but it is very new for them, or too fast for them to adapt into electric vehicle industry. But that's the reason they are investing so much money, and they are rapidly adapting to the electric vehicle industry also. So just as a basic explanation, so I would like to share hybrid, what is the different types of electric vehicles. So, most of you already might know of this, just as a glimpse, I would say. So hybrid electric vehicles, it is having, we cannot plug in and charge charge the battery. That is basic type of hybrid vehicle. So here it uses the engine power for battery charging, and it discharges to battery motor. So that is basic concept of hybrid electric vehicles. So PHEV, which is also known as plug-in hybrid vehicle. So it can be charged by external charger, and it can be powered by fuel. So either way it can be used. And this is also another type. And battery electric vehicles is fully dependent on battery. Okay. So, okay. You can name, okay, as a basic explanation, these are all the basic components of electric vehicles. So you might already aware. As the name says, a battery is a primary component, and it has motor, and it has a controller, and several systems like cooling and DC converter and charging port, transmission, and all many components are there. So let me focus on these 5 major component, and let me try to share you some information about each, what is new in each 5 area. So moving to battery. So as you can see here also, China dominates for the manufacturer. So here's a share of who makes the battery. As you can see, giants are China manufacturers, Cattle and BYD. So these two holds the, you can see, almost half of market. And second is Korea. So BYD is also mainly, it is a battery manufacturer. So there is no surprise that they are leading the electric vehicle segment also. So yes, anyone know what are all the types available in batteries?
Lithium ion. And next, lead acid batteries. Another Gaba. I have only 2 answers received. One is lead acid battery, and another one is lithium ion battery.
Yes. So where you have seen lead acid battery? Any idea? It is very commonly used in households. Inverters, right? Yes. So most of two-wheeler and like as you said, inverters and whatever the power backup we are using is commonly for lead acid. Okay. And lithium ion, can someone give some example? Mobile, yeah, mobiles, laptop, and all rechargeable like small electronic devices is usually using the lithium ion. So what is the challenge? As you can see, mostly used battery type in electric vehicle is lithium ion. So because it is very is my screen visible? Yeah. Okay. So as you can see, this is the power, energy density and against weight. Okay. So x-axis is weight, and this is about the energy density. So energy density is basically how much of energy it can store against its volume, or so here you can see weight and volume. Okay. Volumetric energy density, and this is specific energy density. So lead acid is very low, so it is very heavy, and it is having very less energy storing capacity. And this is nickel cadmium, and another nickel related battery, and this is lithium ion. So you can see the lithium ion is already in the best position it is possible, right? So even though it is a smallest in size and lightest in weight, and still it holds the higher position for energy storing capacity. Right? So that's the reason all small electronic devices can utilize lithium ion battery, and even in automobile also it having major contribution. So challenges. Okay, I already displayed, but I will explain. So one big challenge is about lithium. Lithium is taken from raw material by mining process, and the availability of that raw material is very less. And lithium ion batteries includes some other materials like cobalt, or some other ions together. It is used, and they are also very expensive and very difficult to process, extract from the raw material. Okay? And it has a degradation over time, and so many, after so many cycles, it will be reducing the energy storage capacity. And recycling is a very big challenge. So you might have seen that symbol in your mobile battery or something. So you should recycle it very carefully, right? So the same way, just it is a small mobile battery, and just imagine some thousands of mobile batteries packed together and kept in a car. So how risky, or how precaution we have to take, how much precaution we have to take for recycling that one. Okay. So, and one more challenging point is low temperature. So not so difficult for India, but in other countries, if you in US and North America, many countries, they have to use in snow fall time. Even at that time, the performance will be low for lithium ion batteries. And this situation we have seen many area, right? There is a risk of explosion or fire. So these are all the issues in lithium ion battery, which is a very commonly used in electric vehicles today. So anyone guess what can be the alternative?
Lithium phosphate?
Lithium phosphate, yes, okay. I expect more answers. And I have given the clue in the screen, you can see. Okay. So one more clue. You can see it we use it every day in our daily life.
Sodium based Sodium chloride based battery.
Exactly. So basically, it is a sodium ion battery. So we use there is plenty of availability in seawater, and it is very cheap compared to lithium. It is we can say from lithium raw material, it is just a hundredth of one material cost, and it is easy to extract from raw material, and it is easy to recycle also. So that's why sodium ion battery is considered to be a promising alternative for lithium ion. So still it is not 100% started using, right? So it is like like emerging technology. In earlier days, when they started exploring for a battery development, this was also one of options for sodium ion, also one of concept, which is very similar to lithium ion, but due to the higher performance and manufacturing ability and usability, like versatile power storage capacity and versatile capacity, that lithium ion was preferred, and it was entire industry was focusing for lithium ion. But later period, everyone can understand, okay, lithium is a limited resource. It is has a we have a mining process, and we have to extract material, and it has difficulty for recycling. So while looking for the alternative, then again almost all the battery development industries, they are working on improving focusing again for developing the sodium ion batteries. So as you can see, whatever the development or development or implementation of new technology, the implementation cost plays a major role, because as you know, long back battery was expensive, electric cars was expensive. Comparatively, it is now reducing cost. But if the sodium ion comes into place, it can even further reduce, and almost half of this is the battery pack cost of lithium ion compared to sodium ion. So you can see almost half of lithium ion can be achieved by switching to sodium ion. So the sodium ion we can achieve cost, and compared to lithium ion, we can almost achieve the same capacity of power to weight ratio, and but it is comparatively closer, but still it is less to compare to lithium ion. But there are many advantages, that it is safer, it is low heating and low risk of explosion, and easy for recycling, and it is cheaper. Like as I said, it is half expensive as lithium, and it can perform well in low temperature. And so currently, the main battery manufacturing regions like BYD and Cattle, they have already started manufacturing. They invented the manufacturing technology for like mass production of sodium ion battery, and it is already started adopting as an alternative for lithium ion. So you can see this BYD Seagull. It is launched in last April. It has about 300 kilometer of range. It is made with the sodium ion battery. There are several other new technology evolving, like solid state battery, or as some of you said, lithium phosphate. So there are some alternatives also working on, but because of this availability of raw material and cheaper cost, we can say we can expect more implementation or more adoption of sodium ion in upcoming future. And feel free to ask any questions in between if you have any questions, please. So moving to next motor. So this is some basic information like based on transmission system, how we have what are the types we have as a single motor and a dual motor and three motor concept and four motor concept. Like in single motor only it is same as our IC engine concept. Like instead of engine we have motor and it is only front side driven and rear side is like idle wheels. In dual motors, I must four-wheel drive concept, you can say. Okay. And three motor is like rear side will have individual drive, so which can eliminate the differential and it can improve stability and pickup and performance. In four motors, also like adaptive drive and it is higher efficiency because whatever is needed, like only the required and the calculative power is given to each motors. So comparatively, it is efficient way for user. So these are all the motors used in electric vehicles. So commonly used the 7 types. So as you can see, and this brushed, you might have seen these types in electrical drive and controls lab, right? In our lab. And okay, so these yellow highlight items are commonly used, and this brushed DC motor is conventional, like old type. We are not using in electric vehicle anymore. And this yellow highlight 5 items are commonly used. It is and this right side, it is a newly, I mean, the concept is available, but not available as a mass production or not commonly used as a axial. It is called axial flux ionless motor. Okay, so do you understand the basic difference between radial flux and axial flux? Can someone say? By the name itself, we can guess what is the basic difference. Any guess? Sorry, someone is speaking, or I could not hear anything.
What is the answer? Axel? Wait, Axel? Axel flux. What is the axle flux? Say something. One student is saying the arrangement of magnetic is different in.
Exactly. That's a very good answer. Actually, yes, arrangement of or alignment of magnet, or you can say magnetic flux, is perpendicular in to rotary shaft. in radial flux, okay, and it is inline or coaxial in axial flux motor. So that is a basic difference, as you can see here. Okay. So you might have already studied this topic maybe in electric drive. Okay. So radial flux has a uh, perpendicular flux, and this is as a coaxial. Okay. So what is so new in this axial flux? So it is comparatively smaller in size, means smaller in size, and it can provide more torque output, and it is more durable. Okay. So here is a comparison how against like a torque output of motor. This is radial, which is used as a very common type used in electric vehicles, and this is a coaxial type example. So this is commonly used in all vehicles, and you can see the output torque 40 Newton meter, and it has a 250 bhp, which is, you can see the almost half of the size, half of the weight. Okay, so this is 50 kg weight, and this is just 24 kg, and it is 10 liter of volume, and it is just 5 liter, and you can see almost double the time of horsepower is produced. And almost, if you see about volumetric torque density, it is 4 times higher than radial flux. Then why it is not used so far? Right? So similar to what we said for sodium ion, this concept or this type of motor is already available from very long back, but how to produce it as a mass production, or how to manufacture in the way that it is cost effective. Okay. So that is not established yet. So that was the challenging point to implement it as a alternative for radial flux. Okay. So now, so this, as I said, this is smaller in size and more torque output and better traction control. As I said, it is complex in design and more challenging and expensive to manufacture. So here, anyone heard about this company named YASA? Okay, so it is a British origin company. They are manufacturing for motors. So it is one of the leading manufacturer for axial flux technology. Okay. So in earlier days, for maybe around 40 or 50 years, they already started the axial flux, but it was discontinued, or it was, no one had interest on axial flux since it is because of this complex design and difficulty to manufacture. And but at that time, the Mercedes-Benz bought YASA, and they invested for R&D, and they developed the further invented for the mass production condition and the production method, and they are planning to implement as a alternative in upcoming vehicles. So this is just as a you can see concept of coaxial motor used by, going to be used by Mercedes-Benz. So this will be the first car from Benz to use the axial flux technology. Mercedes-Benz Vision 11. So now it's in concept phase. So far, any questions?
Any questions?
Okay.
Sir, I'm Akash.
Yes, yes, please. Hello.
Sir, axial flex motorல டார்க் அதிகமா இருக்கு சொல்றீங்களா சார்?
Yes.
அப்போ ஹெவி டியூட்டி வெஹிக்கிள்ஸ்லாம் அதான் யூஸ் பண்ணுவாங்களா?
Like heavy duty vehicles we can use, but so far இது ஏன் நம்ம ஃபுல்லா யூஸ் பண்ண முடியல அப்படின்னா we are having, it is a complex design. Okay, so whenever you want to commercialize something, so you have to manufacture it in a cost effective way, or if it is too much complex to manufacture, you cannot implement as a commercialized version, right? As a concept version or one time manufacturing you can do, but if you want to make it as a commercial version, if you want to sell it, if it is too much expensive, for example, if it is 10 times higher expensive than radial flux, why should I buy it? So that is a basic issue. So whenever even whatever may be the industry, the cost or that plays a decisive role. Major decisions are taken from the cost effective point of view.
ஓகே சார், அப்போ ஃபியூச்சர்லயும் ஹெவி வெஹிக்கிள்ஸ் ஐசி இன்ஜின் டிபெண்ட் பண்ணி தான் இருக்கணுமா?
So IC engine dependency, like it is for me, and as many motor legends say, like you can say, you might have heard from Toyota CEO recently. There was an interview about same question. They asked, like, they don't believe EV is the solution. So there will be a dependency of IC engines, that is for sure, but the ratio will keep on increasing. So there is a forecast, the statistical forecast is saying, okay, it can outsell the electrical vehicle, but still, so many, it's not a one day change. It takes a lot of time. It takes a lot of R&D and a lot of investment. And you can see, for example, they have been working for last 20 years to develop this as a commercialized version for this motor. So for example, whatever they are trying now, it is already been worked by last 10 years or something. So it will take time, definitely, but IC engines cannot be eliminated because it has its own perks, like it has own positive sides.
ஓகே சார், அப்போ ஃபியூச்சர்ல ஆட்டோமொபைல் இண்டஸ்ட்ரியில மெக்கானிக்கல் இன்ஜினோட ரோல் கம்மியாகும்?
Very good question. So mechanical engineer don't correlate with IC engines. Okay. Mechanical engineering is a very vast division. Okay, and even without, so as I can understand from your question, so whatever we are discussing so far is, we are not talking about manufacturing technology, or it is so oriented towards electrical or electronics oriented subject. Yes, but still there is a major role played by mechanical or manufacturing industry. Okay, so mechanical engineering is a very vast subject, so it is only one part, that IC engines. Okay.
Okay, thank you.
Vairam, I am having one question. Yesterday,
Yes.
yesterday Tesla has launched a Cybertruck.
Yes.
So please share some views in Cybertruck.
Yes, sir. Maybe I have some points later slide. We will discuss that together. It will be good. So I have some points related to Cybertruck in upcoming slides.
Okay.
We'll discuss that. Yes.
Okay.
Okay, so moving next to motors, we have a controller, right? So have you heard this term ADAS, or Advanced Driver Assistance System? So since it is electric cars, like entire discussion points is more oriented towards electronics control and electrical drive related, but don't think it is not our subject and our other department. Okay, it is a part of our core subject. Yes, so someone can say like what do you know about ADAS?
Sensor. Sensors.
Very good.
It is used in autonomous vehicle. Sensors is used in autonomous vehicle. It is used for detecting the path, lane control.
Lane control.
Land control. Like XUV 700, Mahindra XUV 700, they
Exactly.
have implemented the ADAS in India.
Yes. And the MG Motors, you can say it has ADAS system. Okay, so recently, so this advanced driver assistance system is one of like safety features. Okay, so basically how it works, like it has many sensors, like it takes input from the surroundings and it takes a decision by itself based on the logic program. Okay. So why it is so related with electric vehicles? Why not in IC engines? Any answers? We have ADAS system in IC engines also. So ADAS and autonomous driving is two different topics. ADAS is basically for assisting. Mainly you can say cruise control with adaptive cruise control and like emergency braking. If some obstacle comes in cross, all of a sudden it can brake itself. Don't have to wait for the driver to push the pedal. So these kind of safety features are based on this ADAS system, and all of the automotive giants are investing a lot of R&D for this ADAS. So why it is so related with electric vehicles is, maybe you can see from this image. IC engine construction and electric vehicle construction is two different. I mean, you can if you understand the difference, basic difference between IC engine and normal electric vehicles, you can easily say what is the major difference. So entire vehicle driving input power or a battery management, everything is done by this controller. It is called like electronic control unit, ECU. So this is like you can say brain for your car. Okay, so we can program how it should react to certain situations. For example, there is a sensor. and we can limit some if in certain speed, if it is finding any obstacle in certain distance, it should apply a brake by itself. You can create the logic and you can implement it. So continue, it is a programmable, and based on situations you can monitor all the parameters like fuel consumptions or whatever, or obstacles or surroundings. All these parameters can be monitored by sensors, and it can be taken as an input, and based on the inputs it can order something to the driving system or a braking system. So that is the basic of ADAS. So but implementing this in electric vehicle is far more easier compared to IC engines, right? It is already been controlled by, like, drive itself is already been controlled by control ECU, and it can directly manage it without any additional effort for in case of electric vehicles. So that is why the implementation of ADAS and, as you said, autonomous drive is more easy and feasible in electric vehicles. Sorry, someone asked some question. Okay. So as I said, like this is for assisting, and it has mainly for emergency braking or like pedestrian detection. And for example, it can detect traffic signals, and you can give the warning message, and it can give the like automatic parking assist. Okay, so these are ADAS technology. It is like continuously evolving, and so many features are being add on time every year, I can say. So second is already said by someone, like autonomous driving. So one open question, like anyone knows what is the first car implemented the autonomous driving system? And I added comment, it's not Tesla.
Google, I think so.
No, sir. No,
Volvo?
Not Volvo.
Not Volvo. I think so. It should be Apple, Microsoft, or Google.
It is an automotive giant.
What? It
is an automotive giant.
Automotive giant. Okay.
And it is done way long back than current, like maybe around 30, more than 30 years ago.
Okay.
And so it is actually a Mercedes-Benz. In around 1980s, they implemented the first autonomous car. So it had the features of autonomous driving, like lane changing and cruise control and those things. Okay, so what is so interesting about self-driving and driverless cars in next you might have seen the many automotive expo images or there is a concept of driverless car. Like there is no feasibility, even there is no steering at all. It is automatically driven. So those are all like continuously evolving technologies. Like some area it has been implemented. As you well know, self-driving is already established in Tesla very well. So they are from the beginning they are working for this autonomous driving concept. So they are way ahead. The Tesla is way ahead of other automotive makers. So basically, it works in the same way as ADAS. As I said, it has a lot of sensors and light detection and like a sonar system, ultrasound system. So all the sensor input it takes and it reacts based on the inputs. Okay. So it is like complete logic programmed based on how it has to react and how it has to monitor all the parameters from each sensors. So it is also like a continuously evolving technology, and you might have already seen some videos about Tesla autonomous driving and XUV 700. That is ADAS features, and the MG they have implemented. So maybe we'll move to next one. Okay, so next is about charging. So charging is a major role, right? Of course, we have to charge the vehicle for a certain period to drive until like maybe it takes about 7 hours or 8 hours, very long hours for battery charging. So this is like one emerging technology which is called vehicle to grid. So why do we need it at first? Like vehicle to grid is like the battery of in simple words you can say a battery of vehicle will be used as a energy source for other electric appliances. For example, from the grid, it is like from our EB connection, we are receiving to home house, and we are charging unit. We are connecting, and through charging unit, we are charging our electric vehicle, right? So sometimes when there is a peak load for grid, it can give back some charges. It can. So why do we really need it? It means like there might be a power surge all of a sudden. There is a supply demand peak all of a sudden. So as a long hours we are charging the electric vehicle, so it will be kept connected all the time. So whenever there is a fluctuation, it can support the battery of electric vehicle can support, so that the entire balance of supply and demand can be managed in better. So and some peak loads will affect the battery life for other appliances also. So that also can be balanced. So that is the reason it is being adopted as a improvement point in electric vehicles. So it is like a two-way charger, like how we use our power bank. It has been charging and discharging same time. It can be. So same way, the electric vehicle electric vehicle batteries also will be used while charging. So this is like a recent advancement in related to charging. So any questions so far, or can I move to next?
Yeah, move further.
Okay. So yes, please. Okay. So, like, since I am from the body shop background, so I would like to explain some more details about this body points. So, in body, actually, we are having. You can understand what part of this car. Basically, like if you remove all the small parts in all parts and powertrain, everything from a car, and whatever left is body. Okay? And so, what is important for this? What is the important role of this body structure? Anyone? Any suggestion? Any points? Any points? Anyone can say what is so important about this body?
To mount all the parts, hard parts,
Well done. Exactly. Okay.
and to withstand the collision.
Exactly. Exactly.
Collision strength.
Exactly. You can say like a crash performance, right? So, like what is the main difference between Suzuki and Tata Tiago, Baleno and Tata Tiago? You can say. So, if both collide each other, okay, and you can see maybe almost half of the Baleno maybe crushed down, and Tiago withstands. So the body holds the complete structure, and it plays a major role for safety of a passenger in the instance of crash or impact, anything. Okay. So you can see the lower portion is called platform, and it holds the powertrain together and carries the body. And the upper portion is having all the area where the passenger interacts. Like this is a cabin. So inside cabin, we are having seats and all the trim parts or steering and infotainment systems. Whatever you see inside a car is mounted inside on the platform and upper body. So the basic, any idea like what is the manufacturing method used very commonly in automotive body construction? Oh, sorry, the title is casting, but it is not related to casting. It is not the very common method used for manufacturing that automobile platform or something. It is like a evolving technology, but it is not 100% adapted. Anyone knows?
Sheet metal pressing.
Exactly. Sheet metal
Pressing and assembling with the robots.
Exactly. And exact manufacturing process used for sheet metal assembly, like joining process, you can say.
Spot welding.
Exactly. So the spot welding and like a sheet metal is like you can say like a normal sheet with a defined thickness, maybe less than from 0.65 mm to maybe 3 to 4 mm maximum, is formed in required shape, like a simple forming process, and it is been assembled like a small parts together with generally with spot welding, or wherever there is no access, they use the arc welding. Okay. So this is the primary manufacturing method for automotive body. Okay. So in this, what is so new to know? Like we have been welding, we have been using the sheet metal for so long, and we have been using the same like equipments or spot welding process so long. What is so new about it, and what is it is how it is related to electric vehicle? So if you see electric vehicle, it has a major volume is occupied by battery, right? And battery is very heavy. So, for example, if the battery itself is major, having a very heavy load, like how we have to carry the load along with the passenger and whatever the occupied things. So it consumes a major volume of power, and it requires a major volume of energy to carry that, right? So battery, it is unavoidable. So we are evolving for that, reducing the weight and weight power to weight ratio. We are evolving, but how to carry the weight? That is a big challenge for electric vehicles. Okay, so even IC engines are also heavy, but here anyway we are having motors. So motors, like maybe if it is less, even though if it is less heavier than IC engines, but we will have a heavy, very major load of batteries, right? So you might have seen one news recently. Toyota was recalling its electric vehicle for one issue. Anyone heard that news?
Yes.
The tire was coming like while moving in a certain period, the tire was coming off. The wheel was coming off. Anyone know? So what is the reason? Have you heard of this news first? Okay. Okay. Toyota is like a world leader for automotive industry. So they have very limited electric vehicles. Okay. And they face many challenges while evolving into electric vehicle market. And the problem was due to the very heavy load it has been carrying, and because that while moving and because of that vibration, the nuts which is holding the wheel, it is loosened up, and the wheel comes off while moving. So it is a very very huge risk for safety. So this balancing this weight is a very challenging part of electric vehicle. Okay. So how we can reduce? Either we should reduce the size of. If we reduce the size of battery, it will affect the range. So we should not compromise the range, and we should reduce the size. So that's why we are trying about alternative batteries or alternative drives, which is having less volume and less weight. But even if it is not enough, so one option is body. Like body is completely made of metal. Okay, so there is a scope for improvement. Like we can reduce metal by moving to like alternative composite materials. So if instead of using a normal mild steel iron, okay, so maybe it can be used some high, yeah. So this is like a regular structure. Like you can see high strength tile and ultra high strength tiles we can use. Okay. So by changing to ultra high tensile, we can reduce the number of parts, and we can ultra high tensile means, like for example, if it is more than usual strength of any part will be high tensile strength will be about uh, 300 to 400 around for 400 around for 400 megapascal, and ultra high tensile terms for like more than 1.2 giga, okay, 1200 megapascal tensile strength, 1200 or 1400 megapascal tensile strength, so that we can achieve the crash performance and strength, whatever durability we require, and we can balance the weight also. So that is why the composite material is continuously evolving, and it is a one of big opportunity to balance the weight addition due to the battery. So in related to composite material usage also, there is a lot of evolution is evolution is happening. So there are usage of even carbon fiber also instead of sheet metal parts, and even plastics have been used as alternative for skin panels. So that is another evolving area. And moving back to the casting portion. So in this area, you can see there are a lot of complicated structures assembled. Okay, and this is very crucial for crash performance, and like it is where the suspension is mounted, and we have to use very high strength materials for this area. And instead of making so many small parts and making assembly, we can switch to casting. Okay. So casting is completely different type of manufacturing, and sheet metal assembly is completely different. And you cannot do the casting for using the iron. I mean, it will be too much heavy. So preferred is the aluminum alloy. So if you use aluminum, again, there is another challenge, how you are going to connect with other parts. You cannot weld together aluminum and other sheet metal parts. So there are special joining methodologies for joining technologies for assembling these parts. So what Tesla is doing, they are directly checking for, like they are trying to cast the entire area, like entire front assembly, right? Entire front assembly, they are trying to cast as a single piece. Imagine like how much size it will be required for molding or like casting this heavy structure. And they are trying to use a very big like advanced press machines, like about 9,000 tons, which is about 10 or 20 times higher than the usual machines, press machines. So like many of the automobile industry they are working on implementing this casting method in automotive like body. And as I can say, like entire piece is removed, which is made as a single part. So more than 1,000 spots, spot weld are reduced. Usual case, there are spot welding about 5,000 to 6,000 spot weld is done for each car. So you can reduce a plenty amount of spot weld for by switching to casting. So like someone was asking about why so focused about, like, the entire material was focused about electronics and electrical. So I would like to add some more detail about manufacturing related. So still we have a lot of scope about related to mechanical core, you can say manufacturing related scope. So need not to worry about like losing our space from manufacturing industry to give to electronics. Is any questions for so far?
If you have any questions, you can ask now. Come on. If you have any question, you can ask now. Yeah. Come forward.
Hello, sir.
Hello,
Hi, sir.
hello. Hi.
My name is Manikathan, sir. Third year mechanical. I have one question. Shall I ask?
Yes, please.
Why do e-vehicles slow down in snowy areas, like snowy areas? Why
Yes.
do slow down?
Why does it slow down?
Slow down in snowy areas.
So okay, in very low temperatures, you are saying.
Oh.
Yes. Okay. So as I said, it is depends on what type of battery we are using. Okay. So mainly, as I said, commonly used battery is lithium ion. So lithium ion loses its capability of energy storage or power to weight power capacity, storage capacity in low temperatures. So that is the reason it cannot deliver the complete same output as a normal temperature. So as I said, there is one evolving technology to use the sodium ion as alternative. So if it is successfully implemented, there is a possibility we can drive in snow with the electric car.
That's it. Thanks.
Thank you.
Sir, waste battery லாம் எப்படி சார் dispose பண்ண போறோம்?
Yes. Battery disposal, like another challenging task. Like so, there are some components it can be reused. Like some of lead acid battery. It is we can reuse some of the material, and we have to. So I'm not expert about the battery recycling. So there are certain methods to recycle carefully, and whichever part we can reuse, it can be reused. But with recycling or disposing like without caution, it is dangerous to environment and the human also. Like there is a possibility for example, if we throw that battery in our regular waste, instead of separating it, and they are burning it together with other waste. So it can explode. It can cause some serious damage to human nearby.
ஓகே சார். இப்போ ஜம்மு அண்ட் காஷ்மீர் லித்தியம் ரிசோர்ஸ் அதிகமா இருக்குன்னு இருக்காங்க, கண்டுபிடிச்சிருக்காங்க சார். இப்போ இந்தியா சைனாவோட டாமினேட் பண்ணுமா சார் பேட்டரி?
Yes. So lithium, okay, lithium resource is found in India, right? There is a news. Yes. So yes, a very good point. Actually, there is a lithium reserve is identified in India. So there is possibility, but it depends on how it has been carried away, like how quickly we are like we are starting to extract material, and how quickly we have started to manufacture. Okay, so some company has to start that industry, right? So there is a plan, as I heard, but even the same cattle, which is China giant, they are planning to invest here. Okay, so they may come and invest. You know, our foreign policy is not about encouraging the Indian, like it is mainly about foreign investments, right? Investment based economy. So our economies. So we are open for investment, and we have identified a reserve. But if we allow them to start a company, and they use the material from here, and they make the battery and the cell, so definitely the higher benefit will be for the China, not for India.
Okay, thank you.
Any questions? Yes, sir. No questions from the student side. Yeah. Shall we close the session, sir?
Yes, please. If and not only about the topic we covered today, and if you have any general questions also, please we can discuss if okay.
Yeah, okay. If you have any general questions in automobile, you can ask now. Not about e-vehicles, general questions. Yeah. Hello? Hello? Internship. Yeah, any general questions in automobile, you can ask. We will upload the news. Okay, no questions right now.
Okay. Yeah. Thank you.
Thank you. I request Aishwarya, third year mechanical engineering student, to give the vote of thanks.
Good afternoon. I stand before you with a heart filled with gratitude and appreciation for the immense support and contributions that have made this event a grand success. I would also like to express my heartfelt gratitude to our head of the Department of Mechanical Engineering, Dr. Ayaraja sir, for providing us with unwavering support and encouragement. In conclusion, I want to thank everyone who contributed in any way to make this webinar a resounding success. Your collective efforts have made this event a memorable and enriching experience for all of us. As we move forward, let's continue to strive for excellence and embrace the ever-evolving world of technology with the vision and insights gained from this enlightening session. Thank you, one and all.
Thank you, Vairam, for your wonderful session. In spite of your busy schedule, you have allocated nearly one and a half hour time to deliver the lecture. And nearly 4 to 5 days for preparation for this PPT. I thank you one and all for the wonderful session, Vairam. Thank you.
Thank you very much, Mr. for the opportunity. And, it is my pleasure to meet all young engineers. And yeah, just recently I met some of our college alumni joined again to RNDBCI, Aeronism.
Yes, Venkatesh, one alumni.
Yes. This
2023 joined in Nardizan. Nearly 4 students are joined, I think so.
yes, all 4 of them I met.
Okay. I think so. They are with Raj Khanna, I think so.
Okay.
Rajkumar, ஆமா ராஜ்குமார் தான் இருக்காங்க. Okay, thank you, Vairam, for wonderful.
Thank you so much, sir, for the opportunity, and wishing you all the best, student, for your career. Thank you so much.